Hello everyone from the Novedge team. Good morning and welcome to today's webinar, Laser Scanning for an Integrated BIM Workflow. This webinar is designed to provide a general understanding of how 3D laser scanning technology can be applied to the BIM workflow for building construction. Attendees will see and understand the many different ways that scanning technology can be used to optimize the building construction process, while also reducing project risk, cost, and time to complete. This is great news. Today's presenter, Gonzalo Rodriguez, is a mechanical engineer and a CAD BIM coordinator at AEC Resource. Gonzalo helps solve complex projects for AEC Resource's clients around the world and reducing their cost while achieving outstanding results. And you'll see how very soon. Before we get going, here's an overview of what we do in Novedge. Let me turn the page. Here it is. Novedge is one of the largest online stores for design software. We offer a huge assortment of software solutions that cater to virtually every designer's needs. Put us to the test and come visit our webpage at novedge.com. And for more daily software news and limited time promotions, pay a visit to the Novedge blog and follow us on Facebook, Google+, and Twitter. Coming up next week, how to create stunning digital environments with Eon software. Last but not least, today's webinar is free and it's being recorded live. And if you want to watch this or any webinar episode on our collection, just head on over to Novedge's YouTube or Vimeo channels. And now, without further ado, I'm going to share Gonzalo's screen, and he's going to lead the webinar from now on. Enjoy his demo, and I'll talk to you later.
Okay, thank you. Just a quick confirmation that you can all see my screen.
Yes, Gonzalo, looking great.
Okay, great. Okay, great. So let's get started. This, as has been said, it's a presentation for laser scanning for an integrated BIM process. We're not going to discuss any particular workflow more than looking at the broad range of possibilities of laser scanning. Laser scanning, you'll notice soon enough that it's a very helpful tool for a very broad range of let's say building types or building even process or construction processes. It can be used for under the design, during the construction, afterwards for facility management, and it's your imagination is probably the limit here. So a little bit about myself. I am, as was said, a mechanical engineer. I work for AEC. I have worked on several BIM projects and laser scan projects. I have looked at the scan to BIM process from many different angles. I have even done some surveys myself, so I am familiar with the equipment involved. And I have also produced, checked, and managed the end deliverable of BIM models from a point cloud. Okay, without further ado, I think I already said enough about myself. And AEC's some of the, well, all of the examples that you will see here are, from projects that we've done in-house. So it's nothing's borrowed, nothing's taken. It's all us, and I will tell you some of it, some things about them when we come across the slides. We are partners with Autodesk for the consulting system integrator, which basically is us helping companies implement software or BIM, let's say, within their companies. Okay, so the key learning objectives for this presentation is discover what really is reality capture, 3D laser scanning. There's a lot of confusion, myths that hopefully we'll get to shed some light on that. Will help to discover, give you an idea how does it work and its potential deliverables. We're going to discuss who can benefit from using this tool. We're going to discuss a little bit how why should a client use 3D laser scanning, and when this applied technology turns into an asset. And finally, which software is used for these processes. Okay, there's a broad range of software depending on what you want to do. Okay, let's start it. This is the key question we're going to try to answer. So, basically, what is reality capture? This is a process of taking some real life, I'm going to try to use my own words, not read, some real life object or environment and get it digitalized. This term was developed by Autodesk because, as you know, there are other more traditional reality capture techniques. I mean, let's just think about a ruler, and that's a measurement of reality that you can get into a digital format if you want. But reality capture, as we're going to discuss it today, has its own unique qualities that make it a unique thing. So the recap process starts with the capture. We're going to see more of that later. I'm going to talk too much about that now. And then we compute. The capture is a survey. It's a survey process. The computing basically is everything that it's mostly, hands off. The computer does it almost by its own. You have to give it some rules. You have to use the proper software and make sure the capture has been done. The previous step has been done correctly. So the computing of all that information is a massive amount of information. It's millions and millions of points gets computed correctly. And then is when the BIM process gets into motion, which is actually taking that point cloud and creating a 3D model. We're going to discuss some of that later on. So what is it? Like I said, it's a reality capture methodology. And how does it work? I had some wording on this, but I took it out because I found that it was simpler to try to explain it with my own words. There is some videos on YouTube that you can go and check on its functionality. You can get a visual impact or a visual aid of how does it work. But basically, what you have here is a mirror this at an angle, and this device shoots laser that hits the mirror and gets into a vertical plane. At the same time, this device turns and rotates very fast. So you can imagine that laser beam that starts as a laser beam quickly, let's say, turns into a vertical plane. Okay? And at the same time, this larger portion of the model will rotate around its vertical axis. So you have a vertical plane that's rotating 300 degrees around this vertical axis. That will give us a 360. Well, we're going to look at it's not a 360 because you have a blind spot here that's base, but it gives us a reading, an all-around reading of the environment. For instance, one thing that I didn't mention is that what is the outcome of a laser scan? Basically, what we try to do is replicate an object or an environment by taking multiple measurements of points over the surface of that object. So every measurement will take millions of points and we'll assign them an XYZ set of coordinates, and if we have set it to do so, it will also give it that point an RGB value, so a red, green, blue value, so it's color. So we're going to have multiple points, millions of points over a surface that are going to be with their own set of coordinates and their own color system. You put all those points together and you will get a representation of that surface. What you're looking at right now, it's a power plant. It's in the city of Buenos Aires, Argentina. It's a power plant turned into a convention center and an art center. Some rock recitals have been known to be have taken place there. And this was a very old building that was The intention was to preserve it because it has some really unique architectural details. So the city of Buenos Aires reached out to AEC to scan and preserve all the facade and all the interior of that unique building. So this is the photograph. I don't know how old is that. What you're looking at right now on the screen is a portion of the point cloud, and this is not a model, a BIM model yet. It's just a point cloud. It has been sectioned to look. We have taken some parts out so you can see on the inside of the building. Right here you can see the point cloud and the BIM model overlapping, and then you can see the BIM model. Okay, so it's a pretty neat technology, followed by some adequate BIM modeling skills. You can get a good representation of a building. We're getting another angle at this. So point cloud, again, reality capture, only XYZ values and RGB values to a million and millions of points that are there. Overlapping the model, and finally, we do have a working model. Again, from the inside, this is the stage area, overlapping, and final BIM model. Okay, this is something I'm going to kind of cycle through very quickly because it's the scanning parameters and some inputs that we have to give to the device to make sure that it's doing what we want it to do. But it lands more on the surveyor, and all I'm going to say is that depending on the resolution and the quality and the angle that we want our scan to have, it will be the time of the scan, the overall time. We will take a quick look at this. We're looking, for example, at millions of points, right? 710 millions of points with an X1 quality. This is thousands of points per second that the device does, and this is, the approximate time of the scan. It's 14 seconds. You can note that, we can get from 14 seconds all the way down to an hour, almost 2 hours of scanning, depending of this, values that we set up. For a normal process, most uses a 3 or 4 minute scan per scan, is sufficient. Again, tech things about one particular scanner that we won't be discussing, but if you want to look at ranges and accuracy, there is the manufacturer information on the web page from Faro or Trimble that they got their laser scanning laser scanners. So we're going to discuss a little bit about the process of scanning. The first of all, and obviously, and sometimes it's overlooked or underestimated, is the planning. Planning is key to scanning process because what we want is we want to go to the site and scan, as few times as possible. We don't want to go back to our offices, finish the processing, and find that we're missing an area, or that the client was hoping that some specific area was not properly defined, and we had to go back, right? So the planning is key, is paramount to this process having a successful end product. So define the goals of scanning, determine delivery methods and formats. It can be only a point cloud and that's it, or it can be a full geometry BIM model, or take it a little bit further even and get that geometry model with information. Remember, once again, I'm going to say this plenty, a point cloud and a model generated from a point cloud is only geometry and color. It's not metadata of any kind. So if you want to have that model to have that information, we have to provide it and enter it manually, such as equipment number and stuff like that. And finally, strategically study of the area to be scanned. That is because you have to take multiple scans to get a full reading of the building, and each scan needs to tie perfectly with the next, and there are tools for that, but that's part of the survey process that I don't want to get into because it's a presentation of its own. Then the data recollection, that we take the scans per se, and the unregistered point cloud, which would be these separate scans. The registration is the global point cloud, which is all these individual scans put together into one big point cloud. If you want, you can georeference that if needed, and you can upload it to the web, and the client or whatever stakeholder needs to access it can access and actually look at it from the web. For example, like a Google Street View, and take some measurements and stuff like that without actually having the point cloud on their servers or having a powerful machine, right? This is a different project within the city of Cordoba, also in Argentina. This was a very old buildings, one of the oldest schools, and it's also of very high importance because of the architectural value. So the values that we have, millions of points, X, Y, Z system with a color for every one of those points. What do you get from a point cloud? Well, true view scenes, which is basically what I was talking about when I was mentioning something like Google Street View for you to imagine what it's like. A registered point cloud, black and white or an RGB, okay? Those color can be colored by those colors can be chosen for taking different criteria. For example, I want to color something by height. We can do that, and we can take ranges of height and say, if you're up to so many feet, you can use the green and then transition to blue, stuff like that. Another true view scene. Of course, geometrically reliable 3D model is something I didn't mention before, but there are other reality captures techniques that are around there, but nothing is as precise as a laser scan, because there is there is little calculation done. Only takes the time for the laser to go to the surface and back to the laser. That's all it really computes. It does no other calculation than that. So it's not an algorithm, a mathematical algorithm that approximates the surface. Either you see it or you don't. Either it's there or it's not. And of course, the deliverable of the 3D BIM model and any drawings that you can get from that 3D model, or maybe not, maybe just plain AutoCAD 2D, that works too. This is basically who benefits from that model. Anyone. And I mean anyone. Probably the owner will be the one that gets the most benefit, because it becomes an asset of the building. Even if you refurbish it, even if you go through some renovations, you will only have that part of the building that doesn't really change, perhaps, and you can use it for something else. We're going to go back to this point later on. How can you recycle, let's say, the information of a point cloud? And anyone else, of course, is we're gonna keep going through the examples that I have, and you will notice how these fellows around the table can benefit off of it. Why should we go through the process of getting a scan to be project? Well, because it allows us to use it in different phases of the building's life cycle. Okay, so for example, the basis of design on a renovation project. Okay, this, for example, is a project. It's fairly new. It happened only a couple months ago, when we have this district or this area that the owner wants to renovate. So they want to add buildings to it, and it was offered to them, why not a point cloud that you can use, the design team can use to actually validate what they are trying to do, and getting a good, reading of the actual conditions. So we can see on the screen, that's point cloud for the project. This is the web share. Okay, it's something that the owner can get usefulness from point cloud from almost day one. Once the cloud is processed and is turned into one single big cloud, you can upload that to the internet and get this view, which which is basically works like Google Street View. I've said it one too many times, but it is really the thing that we know the most. And basically, you can jump from reading to reading. Those round things that look like a target are positions of the scan when the measurements and the survey was done. So you can move through those points and getting a 360 view, go up, down, and also taking measurements. For example, okay, a measurement and a BIM model, final BIM model, and the 2D drawings associated. Constructability review. Okay, this one is a nice one. Construction coordination process phases. This is a typical 4-phase coordination process, and we're going to see that laser scanning lands here very soon in the process, because like I said before, I mean, the sooner you get your cloud, the more people will be able to benefit from it, and the most benefits will be to actually get. We're going to look at an example of a hotel in New York City that underwent a renovation process prior to a survey, a laser scanning survey, and digitalization of the existing conditions. This is the building, the point cloud for it, existing conditions. This is how it said we color coded so that you can see how it layers. Every floor has its own set of colors, RGB values, and that is the BIM model built from, or sorry, created from the point cloud. A floor section, floor cut, and we have several of this. I don't want to spend too much time on that, but this is basically a whole set of RFIs that came up even before starting to getting into the whole BIM coordination meetings that we probably most of us know. So this is even before that, even before some of the subcontractors were on board. This is only a bunch of RFIs that came up only comparing the architect's understanding or survey of the building and their intention of design with the actual conditions, and stuff like beams being surveyed by the scan but not being reflected in the drawings were issues that were brought up. Slabs being thicker or lower, or columns being not exactly where the original documentation said they were, or walls being slightly askew, stuff like that. They come up during the this first analysis. All these RFIs that you can see here is a capture of our actual server, how we register RFIs. All of those came up only by just taking a look and comparing point cloud versus design intention. And finally, asset management. Asset management, I mean, is perhaps most used for mechanical plant rooms or facilities or industrial facilities. There is a change, a little slight change of the process that we've used in this sort of projects, because sometimes the accuracy of a BIM model is not really up to standards with the actual site conditions of, let's say, a mechanical plant room. Some industries like oil and gas are very demanding in terms of precision. So we can skip, not in this case, but for example here, we can skip the step of the BIM modeling and go straight to getting information into the equipment that has been surveyed. So we get a 360 photo where we can see the elements, and we can locate the elements in the facility, and we can get some information into that already. This other project did go to the BIM conversion process. Rounding up, added value for the project, and once you have a 3D laser scan, your imagination is the limit. This is what I wanted to go back to. There's a very important aspect of laser scanning and scan to BIM project is that you never know when are you going to need that point cloud. Okay, maybe you started because you wanted to, I don't know, you wanted to survey a mechanical room. And since the surveyor was there, you asked, hey, why not scanning the rooms around it? And then a couple of years later, it turns out that you need to remodel some of those rooms. And hey, you don't need to go and take measurements of anything. You already have your point cloud, and you already have your registry. So you never really know what you're going to use it for. It can be very specific or very broad. I would suggest that, you know, if you can afford it, and if the installation or the facility, it's worth it, just make the best use of the surveyor and try to scan whatever you can, because you're probably going to be using it in the future. Okay, some of the benefits that we've been mentioning as I was going. There's a high definition of the survey in a very short time. This shortens the actual time in the field. You know, for example, in that convention center in Buenos Aires that was retrofitted, there were people that were part of a ballet. They were actually taking essays, and, you know, they were practicing. So we really couldn't interfere a lot with what was going on. You know, imagine an industrial plant that you have to close it down just to have a team of people there for a week, or, you know, who knows how long, to get readings. That doesn't happen with the laser scan. If you planned it well, you can go maybe a couple of hours, you're done. You don't need to interrupt anybody's work, well, no more than strictly necessary. The accuracy, we talked about that already. We're talking about laser, right? Very, very accurate technology. Data reuse, which I already mentioned, and a cost-benefit relationship because of what I said. You know, there is also some things that really cannot be put into numbers, like the personnel safety and the reduced site presence. Just imagine, you know, whatever you need to measure, you can do so from your office, you know, for the safety of your office, and you get a lot of dead time down. Okay, so the engineer doesn't need to take the elevator, go across the street, or to wherever the site is, get a measurement, come back, only to find out that it didn't took it right, or that he missed a second measurement that, you know, he needed. So he can do that from the commodity and safety of his own or her own desk. And of course, risk reduction in design, because we get to validate real soon, almost in real time. If you are designing on BIM, you get to validate what you're doing. Which programs you've been looking at over this presentation? This is the spectrum of programs that we've used. It's not the only programs. I mean, especially Autodesk has been very proactive and understood the benefits behind the laser scanning. So practically now, almost any Autodesk software allows for clouds, for point clouds to be inserted in them, or worked, you know, to be able to work from a point cloud. But this is like the major. There's some things missing, like Inventor and some things like that can also be used with point clouds with a very good end result. Okay, we've reached the time of the presentation that we're going to be hearing your questions, if any.
Yes, Gonzalo. James was asking, what is the name of the online portal for point cloud scan and images? And I'm not sure what he means.
Okay, the online portal. Probably he means, and correct James if I'm wrong, you're talking about the portal where the client can actually go and take a look at the hosted point cloud and
yes, he says yes.
Okay. That is called WebShare. It's called WebShare to Go. With the ones that I showed you is WebShare to Go. That is a functionality, if I'm not mistaken, of Faro laser scan. There might be others, but that's the one that we have used.
Great, thank you, Gonzalo. And that was the only question. Another couple of questions came about this presentation, and they were asking,
Okay.
where can we watch it again? And so I already replied individually that this broadcast has been recorded, and to find it again, just go on YouTube and search for Novedge, and it will be uploaded as early as this afternoon. So enjoy the view on demand of our Novedge webinar. And that's it.
Okay, so thank you all. There is a lot to take in here, I understand that, but like I said, I mean, there is a broad spectrum of things that you can do with laser scan technology, which is why if you want to discuss any of these workflows or any of this particular process, like for design or construction or facility management, here's Mel's contact information. Mel, do you want to introduce yourself to the people online?
No, absolutely, Gonzalo. Again, everyone that's in attendance, if you have any additional questions or you need additional information regarding the scan to BIM process, if we, of course, can be of any assistance to you, please feel free to reach out, shoot us an email, or give us a call directly. We'll be more than happy to respond. We thank Gonzalo and, of course, our partner here, Novedge, for sponsoring this fantastic presentation.
Thank you, Mel. And I also, I have a question. You do help worldwide. Your reach is worldwide, right? So
That's correct. That's correct.
That's right.
So that's good that we have a lot of people from all over, because sometimes we sell software and we can only sell in the US, but this time we're happy to support a partner that can help really everybody wherever they are. So check AEC Resource out, right? It's aceresource.com. And we know they do great work, and not just with BIM or laser scanning. Their offering is huge, and we always like to provide their information when, a small company or big company find themselves in need of an extra push for optimizing the resources, and at the end the costs are lowered with the right help.
Absolutely.
So thank you, guys, and I'll take the screen back, and I'm going to thank everybody for attending. And also I want to remind everyone to visit our page at novedge.com, where you can find the entire, Autodesk product line and all the BIM resources that we talked about. And for information on the latest specials and releases, join the Novedge network on Facebook, Google+, and Twitter. And don't forget, the next week webinar is about how to create stunning digital environments with Eon software. And to rewatch today's webinar or previous ones, as I said, go on YouTube, look for the Novedge channel, subscribe, and you can have many, many webinars in the future. And you can also look back. We have 220 webinars with the ones we recorded today. And just, pay us a visit and check us out. Thanks again for joining us, and have a wonderful day. Thank you, Gonzalo and Mel. That was great.
Thank you very much.
Bye.
Thank you.